Hello, and welcome to another ARM Software Developer Breakdown. My name is Robert Wolf, and you are watching the PARSEC Demo series with Paul Howard, Principal System Solution Architect from ARM. In the last video, we showed you how to add an HSM for PARSEC to your Raspberry Pi. And in this video, we're going to dive a little deeper. If you missed any of the previous parts to this series, cruise on down to the description and find the part that you're on. Here we are with Paul once again. Get ready because we're about to see a demo on how to reconfigure Parsec to use HSM using the same RSA workflow from a previous video in this series. Go check out part 5 and part 6 in case you missed it. Paul, when you're ready, take it away.
Okay, thanks, Robert. So yeah, in the last video, we showed you how to hook up the hardware security module to the Raspberry Pi, and we explained a bit about how Parsec backend configuration works. So today we're going to put that theory into practice, and we're going to show Parsec handling the keys using hardware security protection. The first job right here is to reconfigure Parsec to use the hardware backend. And the first part of that is going to be for me to grab the full path name of the PKCS11 library that came down with the OpenSC package that we installed in the last video. So let's just list that, and I want to get its full name correct and get that copied onto my clipboard. I'll need to point Parsec at this library, so I'll need to paste this into a config file in just a second. Okay, let me just grab this, get this onto my clipboard real quick now. Okay, the next thing we're going to do is just kill the Parsec service because I need to reconfigure it and restart it. A pkill Parsec will do that for us. Let's jump over into the shell where Parsec was running, and we should see that it's now terminated. There we go. Okay, so time to crack open our text editor. Let's go and do that reconfiguration of Parsec. Let's swap everything over to use the hardware secure backend. Now I'm just going to edit the file directly here. This is the default config file that came down from GitHub, config.toml. Perfectly fine to play around with some local changes. Of course, I could also make a safe copy somewhere else, and it would be a simple matter to point Parsec at that. I'm just going to edit it in line here. There's quite a lot in this file. Most of it we can ignore. The defaults are absolutely fine for us. If we scroll down a little bit, we'll come to this section on provider configuration. Okay, you see that right here. And you'll also see that it has the embed provider already enabled, this embed crypto provider type. That's how Parsec was running before. But if we go a little further down, conveniently enough, we can see that it also has this example section on how to configure for a PKCS11 provider. And it's all commented out in the default config file. So we need to start uncommenting this bit. Now, a PKCS11 provider needs a few more configuration fields than the embed one does. It needs a PKCS11 library to load, which is why I grabbed that path onto my clipboard a moment ago, because that's what I need to put in right there. Now, the Nitro key I'm using for this demo has been used previously. It already has a slot and a pin set up, so I'm going to enter those here as well. Refer to your manufacturer's instructions when it comes to setting up slots and slot pins for your HSM. It's usually quite an easy procedure, but it does vary little from one device to another. Okay, let's just set that pin. Okay, we have the OpenSC library, we have our slot, and we have our pin. The only other thing I'm going to do here is I'm going to deactivate the embed crypto provider at the same time. I don't have to do this. Parsec will happily run with more than one provider in parallel. But for this demo, it could get confusing to have two providers running because then I need to start telling the Parsec tool which one I'm talking to. And it would be typical for most Parsec deployments to have a single provider. Because platforms normally will either have a TPM or an HSM or a similar secure backend. Now, Parsec is designed to cope with more than one, but that would be less common. So we're going to keep things simple here. Let's just have one provider running. Okay, that should be our reconfiguration done. Let's go save that config file and let's head over to the Parsec shell here and start the Parsec service back up again. Okay, notice the slightly different startup message. So it now says we're starting a PKCS11 provider, which is a nice indication that our change has worked. So let's jump over into the shell where we're using the Parsec tool. Okay, Parsec is ready, so let's go grab the Parsec tool so we can get an even better indication that it's working. We can use the Parsec tool to list providers again. And this will now come back and tell us that we no longer have an embed crypto provider running, but we have a PKCS11 provider running instead there. Okay, Parsec is now hooked up to our HSM. Let's go do that whole RSA demo all over again. So now you might remember this demo from a previous video where we used Parsec to create an RSA key pair. We used the public key to encrypt some text and then bring that text back to Parsec to decrypt with the private key. Now, if you didn't see that demo, I'd encourage you to go and find it. It's one of the earlier videos in the series. It's going to look exactly the same here. That's the beauty of Parsec. We only have to reconfigure the service to use the HSM, but nothing else is going to change. Let's create that RSA key pair again, this time safe in the knowledge that the private part of my key is locked in that HSM. It's never going to be exposed to any software, but it's otherwise going to look just the same as before. I have a little red LED indicator on the HSM to show that it's working hard, creating that highly entropic key for me. There it is. There we go. Let's export the public key again. Same command. Export public key. Just type my key name. Very little typing to do, because by default it will give me the PEM format. Real convenient for me to just grab that now, get that onto my clipboard. All right, so let's go back over to our website. So this again is the 8gwifi.org website, which can do some RSA encryption for us. Paste the public key in there, and then we'll just type a clear text message. And this website is just going to keep encrypting as I type, which can be a little bit bewildering to watch. But by the time I'm finished, I can just go and grab that ciphertext onto my clipboard. Just need to scroll down a bit to get that ciphertext. There it is in the output window, all nicely base64 encoded for us. Let's go grab that onto my clipboard, and one last visit back to Parsec tool. And there we go, we do the decrypt command. Decrypt with that nice secure private key. Paste in the ciphertext, off we go, the little red LED comes on again, and there we are. We've accessed the private key, we've decrypted the message. And there we have it, the same demo completed end-to-end with all the same commands, this time using real hardware security to store the private key. So our keys are locked safe inside that HSM, they aren't just being stored on the file system anymore. But Parsec handles all of the complexity of talking to that hardware. So when we use Parsec, we don't need to care about specialized interfaces like PKCS11. We have this simplified experience. It looks just the same no matter what kind of secure protection we have on the platform. And that really is what Parsec is all about. It's our platform abstraction for security. And that's it. Robert, it's back to you.
Well, Paul, that was a fun ride, and it's almost over, unfortunately. Still, stay tuned for the last video in this series when Paul does his final teardown and summary of this entire series on Parsec. We will also share resources and point you to some fun ARM developer opportunities. As a reminder, if you enjoyed this video, please don't forget to like it, follow our channel, ARM Software Developers, and we will see you in the next ARM Software Developer Breakdown.